Angles in standard position. We're going to start with this. Angles in standard position. How many of you guys have used a protractor? I'm pretty sure that's everybody. Now, when you look at a protractor, it's kind of like this. So something like that, right? You'd put the flat part on the bottom of the angle. One side here, it would be 0. On the outside, it would come around to 180. And then on the inside of the protractor, it was 0 here, and then 180 to the other side. Something like that, correct? Now, what happens is, as you zero that angle out, you always started at the bottom part. That is called the initial side of the angle. When we start looking at initial sides of angles in this class are always going to occur at the same position. They're going to occur on the x-axis on the positive values. All right? It's just basically you're putting a line there. Now, as you measure upward, as you were measuring these things, you would read the little numbers in here and all that stuff, and you'd say that was about 82 degrees. Okay? You would do that. You just by following your angles through. What you were measuring is called this side of an angle. It's called the terminal side. It's where the angle stops. The angle starts at the initial spot. You remember zeroing it out on a protractor? There was always this little circle that you would put the vertex on. Well, same idea here. In a XY grid, the origin is where you would, we'll call zeroing out our angles. It's where the vertex occurs. So their vertex is always at the origin of an XY grid, and the terminal side is where the angle stops. So if I'm looking at this angle here, this tells me that it started at 0, it passed 90 degrees, and it wound up somewhere between 180 and 90 degrees. It appears that it's about halfway. So halfway would be, what, 135? We'd say that's about 135 degrees. Right? So as we go to draw our own angles, we have to be able to label what quadrant they land in. Every time you draw an angle, your initial side always is at the positive values of x. And you move, for any positive angle, you move counterclockwise. All right? Do you remember what your quadrants were? Which one's this? Well, this is the only time that you use Roman numerals anymore. Okay? So, what's that? Oh yeah, humanities 1, 2, 3, and 4, or the chapters, right? Chapter X, X, I, V. So what you have here. Oh, I thought that was sorry. As you go through these, you do have to tell what quadrant the end is. So you just have to remember to use your Roman numerals. It's no big deal. So what you're going to have now is stuff like this. Let's say I want to figure out where a 210 degree angle is. What I do is I draw an XY grid. 210 degrees, well that's more than 180, but it's less than 270, correct? So it's somewhere in here. And what quadrant is that? 3. Exactly like that. All right.
So it's this the graphic thing, is just sketching it out.
Yeah.
Right.
Yeah, I'm not going to give you a protractor or anything like this, but I do need to do this real fast because it's driving me nuts. It is way off for some reason right now.
Ding, 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 ding.
Yeah. Ding, ding, ding. It'd be funnier if every time I pressed it, it yelled, ow. Now, I have bubble wrap for the smart board. Anyway, so let's say you want 540 degrees now. What's that? Yeah. If I go 540 degrees, that's more than one revolution, isn't it?
Yeah.
All right, let's figure that out. That's 360. 360 plus 90 degrees is what, 450? Is that 5? Then that's 540, right? Is that on a or in a quadrant? No, it's not in a quadrant. It's on what axis? It's on the x-axis. So it's on the x-axis. Remember, if it lands on an axis, it's not in a quadrant. It's just on the x-axis. Do you notice how I just spiraled around until I found out where it wound up? All you're going to have to do is just kind of figure out how many times you got to go around the circle. How many times does it take you to get around to find that spot? And it works the exact same way if you have a negative angle. If you have a negative angle, instead of going counterclockwise, which way do you think you go? Clockwise. Exactly. So if I have a negative angle, let's say I have negative 60, something really easy to look at. Yeah, I'll show you. It's just like you said. If I have a negative angle, instead of going clockwise, I go counterclockwise. I go counterclockwise, 60 degrees.
I mean, like, in a triangle or in a circle or anywhere, you have a negative.
This isn't a triangle. But I know what you're getting at. What is the functionality of a negative angle?
Yeah.
There really isn't one. But we can create a coterminal angle that has a positive value to it.
Okay.
Here's what I'd like to do, Isabella. Do me a favor. Will you stand up for a second, please? Now face the board. What I would like you to do is turn to your left 90 degrees. Okay. You're facing Kayla and those guys, right?
Yep.
Say hi.
Hi.
Now, face back towards the board. Turn to your right 270 degrees. 90, 180.
I'm like here-ish, kind of.
No. You're the same place you were earlier. Think of it this way. If you are driving a car, if you make a left turn,
Two wrongs don't make a right.
if I make one right turn, 3 right turns, I'm still going that way, aren't I?
Yeah.
So basically what you're doing is you're finding a coterminal way of going around the block. So instead of having a negative 60, what we have is what we call a coterminal angle at 300 degrees.
Okay.
Which leads me
It's like I understand it.
which leads me to the definition coterminal. Well, unless you're numbering.
Okay.
Now, and this is it's the exact same thing that happened last hour. Someone asked, well, what's the real practicality of the negative angle? There really isn't a huge practicality of the negative angle, but what happens is that you can find the coterminal angle, which is positive, which allows you to do other things. The negative angle just tells you you're going another direction. That's it. You're not finding a negative angle of a triangle. You're not going to have a negative angle maybe you would have a black hole or something, but not in real world terms. So a coterminal angle are basically two or more angles that share the same terminal side. They're just going other directions. Or if I stand up, I do 360 degrees, and if I do that again, I'm in the same spot. If I do that again, I'm in the same spot. So every time you circle around something, you're still going to be in the same spot. So 360, 720, 900, they're all coterminal with one another. What you wind up doing if I start with a 45-degree angle and I want to find a positive and a negative coterminal angle of 45, what I'm doing here is I'm adding 360 degrees and I'm subtracting 360 degrees from that 45-degree angle. So think about if you go 45 degrees, if I go another 360 degrees from that, how many degrees is that? What's 360 and 45? So that's 405. If I go the other direction, I subtract out to get the coterminal angle. 360 minus 45. negative 315. They're all the same angle. They all share the same terminal side. All it's showing is that one of them's negative, one of them's positive. Correct. Yeah. And sometimes you might have to, in order to find the negative angle, you might have to go around more than once. All right. If you're at 700 degrees, you subtract 700 or 360 from 700, you're still not negative. You got to go around until you become negative. Let me show you what that looks like. It is, but if you're trying to find the negative value, the negative angle itself, if you take 700 and subtract 360, you're still positive. Keep subtracting until you become negative. Yes. If you subtract it once, and as soon as it becomes negative, you're fine. Like 60 degrees or 45 degrees, I subtracted 360, I got negative right away. If I'm at this example here, I'm at 495. Okay? If I want to figure out where the 495 is, to start with, 360 degrees, it winds up somewhere over in here, I believe, 495. Okay? That would be 495. In order to figure out the negative value, if we subtract 360 from that, I'm only at 135. See how I'm not negative yet? I got to subtract another 360 degrees to figure out what the coterminal angle would be negative. That's all. Since this looped around more than once, I got to unwind it to find the negative.
So you don't want to draw it more than once, you just have to subtract it more than once?
Yeah. Yeah.
Why didn't you just like
It's going to ask you for one positive and one negative.
So all you do is add the 60.
Right. That's really all there is. That's really all there is. And when you practice through some of this stuff, it becomes very evident. It's very, very straightforward. All right. So this leads us into the real fun stuff. Like Mr. Thames was talking about. Radians. Radians. Think about circumference. The circumference of a circle. What is the formula for circumference of a circle? That would be area. Pi times the diameter, or 2 pi r. Basically, and remember what circumference meant? Circumference meant the distance around a circle. Okay? The distance around a circle is the circumference. We all know that to be 360 degrees, or 2 pi times the radius. So what happens here is that within a circle, to go around the circle is 360 degrees, or 2 pi. One full revolution of a circle is 2 pi. Half a revolution would be half of 2 pi, which is pi, which is also 180 degrees. You with me on that? Halfway between 180 and 0 is 90 degrees. Halfway between pi and 0 would be half of pi. Pi over 2. Halfway between pi and 2 pi would be 1.5 pi, which we write as 3 pi over 2, 270 degrees. So what we get here are what are called radians. Radians and degrees are kind of like the metric system to inches. Okay. Radians and degrees are just another way of writing angle measurements. If you do not see a degree symbol, it means it's in radians. If you see a degree symbol, it's in degrees. A lot of times if you see something in terms of pi, you are automatically in radians. There is a very, very simple conversion chart to go between the two. I'm going to show you guys how we convert radians to degrees, and then I'm also going to walk you through the unit circle, all the important angles. So let's take a look at the conversions. To convert between radians and degrees, or degrees to radians, I should say, to start with. Sorry, I'll go back up. I just want to move this down. To convert from degrees to radians. To convert from degrees to radians, you take your degrees, divide it by 180, and slap a pi next to it. For example, if I wanted to figure out what 30 degrees is in terms of radians, I take 30, divide it by 180, and I slap a pi next to it. Now, when you're dealing with all these fractions, don't freak out. You don't have to do them by hand. Get anything on you? Take your calculator. 30 divided by 180. Math, enter, enter. It simplifies the fractions for you. Slap a pi next to it, and you're done. So this one you get pi over 6. I heard you say 1/6 pi. A lot of times if it's 1 in the numerator, just put pi in the numerator. Yeah. The second one?
One on the bottom.
Here? This was the example. I'm just saying, let's say you have 30 degrees. Say you have 30 degrees, you have 80 degrees, whatever. That's all you're doing. Okay? So all you have to do is simplify a fraction, math, enter, enter, and slap pi next to it. It's that quick. To go the other direction, you just do the opposite. To go from radians to degrees, well, your radian values are usually going to have pi in them. So what you want to do is you take the radian, you multiply it by 180, and you divide it by pi. You just go the other direction. So for example, let's say you had 5 pi over 4 was your radian measure. It was 5 pi over 4. I want to convert that to degrees. Well, I multiply it by 180, and I divide it by pi. When you write these out, you should notice that your pi's cancel. Okay? Now, it should be relatively easy. 4 goes into 180, 45. 5 times 45 is 225. Or if you don't know how to do that by simplifying fractions, take 5 divided by 4, hit enter, multiply it by 180, there's your answer. Or 5 times 180 divided by 4. You're going to get the same result. Okay? It is very straightforward. There's no tricks to it. It's just, remember, going from degrees to radians, it means you have to have pi in your answer. And to go the other direction, you won't necessarily have any pi left. Okay? This is a very simple thing to do. So what I'd like to do with these radians and degrees is start with the unit circle and walk through all the important angles. The unit circle. Don't draw that. This is something that we use a lot. No. One of the things I will tell you guys, I am notorious for asking you to fill in the third quadrant, or the fourth quadrant, or the second. on quizzes, short quizzes and things, I will just give you a unit circle and say, fill in this. Now, what we're going to do today is talk about the degree measures and the radian measures. That's only about half of what we can do on the unit circle. And we have plenty of time. So what I'd like you to do is everybody got one yet, or one more? I think there might be some spares in this, or otherwise. Okay, could you hand over? Thanks. What I'd like to do is kind of show you guys a real easy way of setting this up. Let's start by filling in angle measures. And as we do this, I want to put my angle measures on the outside, and then I'm going to put my radian measures on the inside, so you can decipher between the two. It's pretty easy to know which one's which, because one has pi, the other one doesn't. So we start here. 0, 90, 180, 270, and 360. Do you agree on that? Okay. Now, as you go through, remember yesterday I referenced the idea of making sure that we remember some very important angles. 30, 60, 45. You'll notice there are 3 angles here. Boom, boom, boom. Which one do you think is the 30? The first, the second, or the third? Okay. Then what? Okay. Now, going here, do you think I'm adding 30, adding 60, adding 45? So you're at, what is that, 120, 135, 150. Continuing. 180 plus 30, 210, 225, 240, 300, 315, and 330. Those angles that we have up there, what is it, 4, 10, 16, those 16 different angles we have up there, guys, are the ones that you're going to see the most of. What I'd like to do now is take a few minutes and convert all of those angles into radians, which means I'd like you to take the degree value divided by 180 and slap a pi next to it. Now, for the sake of time, you have do the first 2 quadrants. You guys do the second 2 quadrants. Take a couple of minutes and try and go through that. And then we'll go through and write them all in. Okay? Yeah. I know, there's a lot more over there than there are over here, so whatever. You won't. You shouldn't. If you got a decimal, convert it to a fraction. There. So it becomes pi over 6. Remember, if your fraction is 1/6, when you slap pi next to it, just put pi in the numerator. So it becomes pi over 6. All right? It's a more of a standard way of writing it. The rest, what's that? Yeah, and even if you have, like, let's say it's, 3 remember how we had the one was like 3 pi over 2? If you write it as 3/2 pi, it's no big deal. But normally you're going to see it as 3 pi over 2. It just, I say it as, some people say 3/2 pi, but it all means the same.
Can you get sentences?
Absolutely, absolutely. And there's going to be a real nice shortcut that I'll show you here at the very end to help remember all of these values. Pause this for a second. I'm going to start filling them in so that way we can make sure everybody gets all their answers. As you start going around the unit circle itself, when you had 30 degrees, did you guys have pi over 6? Yeah. So it went pi over 6, pi over 4, pi over 3, and then pi over 2. Do you agree? I want to show you something real quick here. Each time you're going from 30 to 60, every time you go up 30 degrees, did you notice that you went up 1/6? 1/6, 2/6, same thing as 1/3. 3/6, same thing as 1/2. If I go another 30 degrees, it's 4/6, which was 2 pi over 3. If I go up another 30 degrees, it was 5/6, so it was 5 pi over 6. you guys see that little trick there? Every time you go up by 30 degrees, you're going up by 1/6 of a fraction. Here, bless you, here you have pi. Here you would have 7 pi over 6. At 240, it was 8 pi over 6, so that's 4 pi over 3. Here was 3 pi over 2. Here was 8 pi, so it'd be 9 pi over, so 5 pi over 3. And then here was 1 pi over 6. And lastly, it was 2 pi. And then to do the 45s, as you do the 45s, you went pi over 4, 2 pi over 4, same thing as 1/2. Here was 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. The trick to the unit circle is every 30 degrees is 1/6. It's a fraction of 1/6. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, all the way around. And each one of those just gets simplified and slap a pi next to it. As you're going up by 45s, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. I'm doing the robot. And that's what you use. Now, as I've said, this is the first time you've ever seen the unit circle. These are the values of a lot of the trig stuff as we go forward that you will, like Mr. Tame said, is if you don't, one thing you'll learn is that the sine of these angles, the cosine of these angles, it actually gives you the coordinates. And that's going to be the second part of these things as we get into it. We're actually going to learn all of the ordered pairs for all of these angles. And once you learn one quadrant, it's a matter of knowing where your x and y values are positive and negative for the other 4 quadrants. Okay? I'll leave this up for a second for you guys so everybody else can finish filling that in. What I want you guys to work on tonight for homework-wise, and let's put it up here as well so that way you guys can finish it up. There is another little part to this section. We're just running out of time. I'd like you guys to work on page 780. Numbers 28 through 58 evens, please. All right. Please don't lose that unit circle. If you need a hole punch, I have one back there. You can throw it in your notes and all that. Okay. Let me just stop where this is at so we can compile, and then I'll blow it back.